Hi, my name is Emily Lakdawalla, and I'm Senior Editor and Planetary Evangelist for the Planetary Society. I think that most of you have probably seen this incredible photo of Saturn released today by the Cassini mission. I think everyone agrees that it's an amazing photo, but it can also be a little bit difficult to understand. So I thought I might explain some parts of it to you so you could understand better what's going on and what it took for Cassini to create this absolutely incredible image. The data for this image was taken on July 19th, 2013. It's composed of 141 separate images that Cassini took of little frames, bits and pieces of this image that had to be combined into color images and then stacked together and carefully blended so that there were no visible seams. It's an absolutely incredible piece of image processing work, and I've got to hand it to whoever was the poor peon behind the scenes who managed to put it together. Now, in order to take this photo, Cassini is an orbiter. Cassini circles around Saturn. It actually goes in elliptical orbits around Saturn. And at different times, it's on one side or another of the planet. At the moment that it took this particular photo, Cassini happened to be behind Saturn as viewed from the Sun. And what that means is it offers a unique opportunity for Cassini to look directly toward the Sun and yet use Saturn's disk to block out the sunlight so that we can see the sunlight shining through all of Saturn's rings. Now, Saturn's rings are not a solid object. They're composed of innumerable tiny particles, some of them big, but most of them very, very small, most of them dust-sized. And so a lot of the ring system looks quite bright in this image for the same reason that you can see dust motes shining brilliantly in a sunbeam. It's something called forward scattering, where very small particles, they forward scatter light toward you. So if you have a light source in front of you, then things that are dusty will shine up in light very brilliantly. So that's why the ring system appears so bright in this image, because it's very dusty, it's not completely opaque, and we're seeing sunlight shining through it being forward scattered to the observer. Okay, so we have the Sun being blocked out by the bulk of Saturn's disk, and here, of course, is Saturn's disk. I'll zoom in on it a little bit. Now, if Saturn's disk is blocking the Sun, that means we're looking at the night side of Saturn. So you would expect Saturn to be completely black if that were the case. But it's not. It looks kind of brown or even yellowish in some places. The reason that it's not completely black is because Saturn's rings are shining very brightly, reflecting the sunlight, and a lot of that reflected sunlight is striking the night side of Saturn. So particularly in these places over here, if you were standing on Saturn's cloud tops up here, you would see this arc of brilliantly lit rings arcing up into space, and that ring light would be shining down on you, much brighter than the full moon. It would be really a pretty incredible sight to see. Another interesting thing about Saturn's disk is that if you look around the edge of it, you will see that it too is really brilliantly bright. What you're seeing here is sunlight being refracted through the atmosphere toward the observer, toward Cassini. And it's not a place where the sun is above the horizon. It's a place where the sun is lighting up the atmosphere. These are all of Saturn's sunrises and sunsets being made visible at the same time in this unique geometry from Cassini being behind Saturn. You can also see Saturn's shadow being cast upon the ring system up here. That's what this black crescent is. So Saturn's shadow makes kind of a tube into space. Cassini is sitting inside that tube, but the tube is angled slightly upward with respect to Cassini's point of view. So you can see the shadow up here, but you can't see it down here because the shadow is being cast slightly up from Cassini's current perspective. All right, now, what is going on with the rings as they cross Saturn? Well, if we look at the bottom of the image, you can see that the ring system, which is essentially a disk, the rings go behind Saturn as seen from Cassini. That means that as you follow the rings around, they are passing in front of Saturn as seen from Cassini up here. Now, what happens as they cross in front of Saturn? Well, most of Saturn's ring system is really very thin. There's almost no stuff there. It's just very thin dust. It's really pretty transparent. There are only two main parts of the ring system that are largely opaque, or at least nearly opaque. And that's the A ring, which is this part, and the B ring, which is this part. The B ring is the most opaque part of Saturn's ring system. It's made of the largest particles with the most particles that are packed closest together and has most of the mass of the ring system. And you can see as it crosses in front of Saturn's disk here, it's blocking our view of Saturn's ringlit night side. And so you're seeing Saturn's opaque B ring blocking our view of the night side of Saturn over here. The A ring is not as opaque as the B ring. It's made of smaller particles that's semi-transparent. So as the A ring crosses in front of Saturn, you can see through it a little bit to see that kind of yellowish ringlit night side of Saturn. But you can still see that the A ring is blocking some of the light that would otherwise be reaching us from the night side of Saturn. The rest of the ring system is pretty transparent, which is why there's almost no other shadows being cast over here. You can see some really faint little whiskery shadows here from Saturn's C ring. And that's all of the stuff that's in Saturn's C ring. It's not very much, but once you cross into view over here where it's lit from the sun, lit from behind, all of the dust in Saturn's C ring is brilliantly lit up, forward scattering all of that sunlight toward our eyes, and so we can see all of this really cool structure in the C ring. And finally, we have the D ring, which is visible where it's forward scattering sunlight to us, but you just can't see it at all as it crosses Saturn's disk. Now, as you go out from the main ring system, you get to the brightest part of the rings as seen in this geometry. And that's this brilliant bright line is the F ring. The F ring is particularly dusty. It's a ring that's shepherded by a couple of little moons, and you can just barely see one of them over here. I'm going to zoom in on it. And there, this one is Pandora. That's the outer shepherd of the F ring, and it's one of the things that's keeping the F ring in place. Somewhere else is Prometheus. That's the inner shepherd of the F ring. Now, what else is going on with others of Saturn's moons? Well, probably the coolest moon to look at from this point of view is Enceladus. Enceladus is the moon that's making this gigantic, diffuse band of ring distant from Saturn called the E ring. And we can zoom in on Enceladus over here, and you can see its geysers in action, spewing all of those ice crystals into space. You can even see Enceladus's shadow being cast onto the F ring back here. But the lighting geometry of Enceladus here might be kind of confusing to you. Why does it look like it's lit with a half phase? It's lit on this side and dark on this side. If we're looking directly at the sun, shouldn't we be looking at Enceladus's night side? The answer is yes, we are looking at Enceladus's night side. We can go over and look at a different one of Saturn's moons to see that. Up here, you can see Mimas. And indeed, we're looking at Mimas's night side. It's a black disk blotting out the dusty forward scattering light from Saturn's rings, and you just barely see a crescent of Mimas being lit up. You're also seeing its shadow being cast onto the ring system over here. So why does Enceladus look like that? And if we zoom out even more, you can see an even weirder looking moon down here. This one, I thought it was Titan at first because it was so yellow, but it's not Titan. In fact, it's Tethys. It's one of the icy moons of Saturn. Why does it look yellow, and why does it not look black? Because shouldn't we be looking at its night side? We are looking at its night side, but we're looking at a night side that is being lit up by this enormous yellow planet that's floating in its sky. We're seeing sunlight that is reflected off of Saturn and falling on Tethys's night side, and that light is colored yellow because it reflected off of Saturn first. Up here, Mimas's night side is not lit up because Mimas is in between Cassini and Saturn. So its night side is not looking at Saturn. It's looking at empty space, and so its night side is black. Okay, anything else to show you in this image? I guess another cool thing relating to rings and moons has to do with a discovery that was confirmed actually in this set of image observations. And that's that all of Saturn's moons appear to be associated with some dusty ring material. We can look at a brightened version of this image, and you can see up here, this is the E ring, this bright thing. But down here you can see another little maximum in ring brightness. This one is a ring associated with a tiny moon that Cassini discovered called Pallene. Similarly, there's another little bit of ring material here that's associated with the moon Janus. Janus is a little bright spot right here. And that little bit of enhancement of ring material goes all the way around Saturn. With these observations, the Cassini team confirmed that there are complete rings associated with each of these small moons of Saturn. And I guess the last and cool thing to show you in this set of images is the other things that are not in the Saturn system that are visible in the photo. And that's several planets. We have up here Mars, which is very far away and not very bright. We have Venus, whose brilliant clouds are reflecting sunlight, so even at this great distance from the sun, Venus appears bright. And if we go down to the lower right corner, we can see Earth and the Moon. In this particular wide-angle shot, the camera was only barely able to resolve the separate light of Earth and the Moon, but it did just manage to separate them. And if you were standing outside waving on the day that Cassini took this image, there's a small chance that a single photon from your hand may have reached Cassini's cameras when it took the picture. So I hope you participated in that, and I hope you enjoyed this little tour of an absolutely incredible photo. Thanks so much to Cassini for taking it.